Once again, welcome to Physics STPM. Cambridge A-level students also can find it helpful, quite similar syllabus. Let us make a start. Right? Yeah. I'm on YouTube, I'm on Facebook. You are welcome to subscribe to it. Today we'll go to projectile motion. Right? Or another way of saying is motion in 2 dimensions. Normal on a straight line. Right? This is one of the book in the market for STPM students can use it. In fact, I use it with my student. Right? This is a syllabus for STPM student 960. We are now under projectile. Right? We are going to look at projectile motion without air resistance, and then after that with air resistance, and then there will be another video on solving problem. A-level student, this is a syllabus for next year onwards, 9702. Describe and explain motion due to uniform velocity in one direction. Right? Uniform velocity in one direction, usually is horizontally. Uniform acceleration in the vertical direction. It can be acceleration, it can be deceleration, right? That's the general term for acceleration. Right? It's under kinematics. So that's just review. Under quantity, physical quantity, we define. We just use the quantity and then we just get how to find the unit. But from this topic onwards, kinematics, we will define new term. Right? Each quantity will define. Under physical quantity, we need to know whether it's a scalar or vector, and then we will use the appropriate method to solve the problem. And then we also study under topic 1, magnitude, right? How big? And then we know that it's not a fixed number. There's uncertainty there due to random and systematic error. And then the quantity must have unit. The quantity, the size or the magnitude, and it must have a unit. Okay, this is motion in 2 dimensions. Right? Just to show you, you want to send a projectile from a ship to hit the tank. What are the things you need to know? Right? Usually we call it non-linear. That means it's not on a straight line. Right? You can see the path is a curve. Or we call it 2 dimension or projectile motion. Right? We'll be using the equation of linear motion, linear acceleration. And then after that, we look at effect of air resistance. We look at no air resistance. After that, we look at effect of air resistance. For A-level student, this is topic 2. These are the textbook, or there are others in the market that you can use. Okay, so for A-level student, it's called describe and explain motion due to uniform velocity in one direction. That's uniform velocity in one direction, usually it's horizontally, and uniform acceleration perpendicular direction. So usually it can be downwards, vertical direction, it can be downwards or it can be outwards, doesn't matter. Right? Uniform acceleration. Horizontally, uniform velocity. Vertically, uniform acceleration. The two are perpendicular. Right? So to destroy a tank with missile, what variables do the captain of the ship consider? The ship is here, you want to fire. What is it to consider? Right? We will look into some of this. For this lesson, we need to know the distance. How far the ship, or we call it the range. How far is a tank from the ship? You need to know how fast is a tank moving. And we need to know the speed that we need to use here, or speed and angle. or we call velocity. And then we also need to know the effect of air resistance if we want to heat the tank. And also we need to direction of wind speed, because we won't go into all these complications. We are only simple solving problem. Right? Example of non-linear motion. Right? Or we call it motion in a plane. Projectile motion. Right? You can join this website to play with some of the animation. These are example. Air power rocket. Another example, throwing a ball horizontally, throwing a javelin, like this one in Olympic. Firing a cannon, this can be a cannon, or a person jumping on a springboard to the pool below. Right, let's just review. This is what I call troposcopic photo. That means you do it in a dark room. You take the picture of the ball at probably 1 second interval. So your camera is going to be on for at least 4 seconds. And the stroboscope will be a light source, right? It will flash every 1 second, and every 1 second, it will capture all this image. Right? So this is an image for uniform velocity. No air resistance. We are looking at no air resistance, or we call it negligible. Right? Uniform velocity. Example, a ball moving at 10 meters per second in a straight line. So every 1 second, it moves 10 meters. Every 1 second, 10 meters. Every 1 second, 10 meters. That's what it means by 10 meters per second. And then the only equation that we use to be, you want to find distance, is the speed or the velocity times your time. X to show its horizontal velocity. Right? Dropping a ball, right? There's your vertical uniform acceleration. Velocity increases uniformly. There is 10 meters per second every second. Right? The displacement in this case also increases. Not uniformly for the displacement. Right? As we can see, you drop the ball, 0 second. Right? Every 1 second, increase by 10 meters per second. Right? From 10, 1 second later, 20. 1 second later, 30. 1 second later, 40. Whereas the distance is different. Initially, it's 0. Then it's 5 meters. Then it's 20 meters. Then it's 45 meters. Right? That distance, 45 meters. That's 20. That is 5. That's 0 initially. And then we remember we are using equation of uniform acceleration for this type of motion. I need to remember all this formula. Right? It's for the case if we round off the acceleration to 10 meters per second minus 2. That means every second, the velocity increased by 10 meters per second. That's what this means. Right? Throwing a ball horizontally from a cliff. Right? So we can think of the motion. That's a cliff. Right? Height, something as height. Uniform velocity horizontally. Right? That's why every 1 second it moves. 1 second, you can see the motion. Then uniform acceleration vertically downwards. Right? Uniform acceleration vertically downwards. So every 1 second, there's the distance. We are combining these two together. So at any time, we combine the motion independently as vectors to find the velocity. Right? So we can find all these different positions or different velocities separately, same as here. and then we just combine. The first second, combine the red vector and the red vector. Right? The second, we combine the pink vector and the pink vector, right, to find the resultant vector, and so on. Right? The second, the blue vector, horizontally is still the same. Horizontally, it doesn't change. Vertically, the velocity increases. There's a horizontal vertical velocity. And then finally, the fourth second. Okay, this is a troposcopic photograph. You want to show that without air resistance at low speed, this one is moving horizontally. This is dropped vertically at the same time, same height, and same height, same time, same height, same time. Right? It means the vertical is the same, except that it's displaced because it has horizontal velocity. Right? This is down in the dark room. Ball dropped vertically at the same time, another projected horizontally. Distance the ball moved horizontally depends how long the ball is in the air. If there's the ground, there's the distance. If the height is higher, then the horizontal distance move will be further away. That's what this means. Right? It depends on the height the ball is thrown. Okay, so this one is for both balls. Dropping the ball vertically, and one is thrown horizontally at the same time. Or you can do a simple experiment, a table there, a marble, another marble there. Right? You just hit the marble, swing it so that this one drop vertically downwards. This one will go horizontally. That is what some of you may have done in your school, in STPM. As I say, you can visit this some of these websites if you want to play with how we change the velocity affect the range. Right? Animation. Okay, so general projectile motion, instead of the acceleration is downwards, right? Wherever you throw at an angle, the acceleration is downwards for gravity. Then we resolve the vector into, so vertical will be deceleration, and then horizontal will be uniform velocity. We can resolve this vector into two, one vertical velocity, one is horizontal velocity. And be aware that vertically is deceleration if it's going up, and then horizontally is uniform velocity. Okay, let's make a start. The variation of horizontal and vertical component of velocity. That is our velocity of projection. V, or we call it V naught. Object thrown with a velocity V naught, not just to show the initial, right? Not this original, at an angle of alpha. This is angle alpha to the horizontal. Right? So we resolve the velocity into V naught x. That means this is the initial horizontal component, or initial component in the x direction. And replace that velocity with V naught y, initial vertical component in the y direction, or vertical component. Then we can show, right, where the velocity at any time we can resolve it into its component. Right? So at any time, it's Vx, horizontal component, vertical component, Vy. Right? At the top there, at the highest point, right? Remember, at the highest point, it cannot go any further. Vertical velocity is 0. Horizontal is still the same, it doesn't change. All the horizontal velocity is the same. There's no air resistance. Right? So h is the maximum height. So as it turn down, right? As it keep on moving, the vertical velocity is now downwards. Same height, same vertical velocity, same vertical speed, but direction of velocity is now downwards. Horizontally still the same. And you reach the ground with the same velocity, same as that, except direction changes as well. horizontally is still the same as the initial velocity. Vertical one also still the same, except, and this is called the range. Vertical one still the same, except it's downwards. Velocity is downwards. This one is upwards. Vertically is accelerated when it go up. Coming down, the same acceleration, except the vertical going up is deceleration. Coming down is acceleration. The range is just a distance travel from start to where it reached the ground. So Vy, the vertical component, decreases to 0 and then changes direction. Right? The thing to know is the horizontal component of velocity remains the same, no air resistance. Vertical component of velocity Vy decreases as the object moves upwards, right? Decelerate, and then it accelerate when the object moves downwards. Right? So we can think of the motion as horizontally, that's the motion. Uniform velocity. Okay. So if the acceleration is 10 meters per second minus 2, then every 1 second it increase by, horizontally, there's no acceleration. So uniform velocity, that means the velocity is always the same. Right? It has not increased. The distance traveled every 1 second is 10 meters. And vertically, it's like throwing a ball outwards there. Right? We are combining these two motions. So vertically is uniform acceleration. The ball is being thrown upwards with a vertical velocity. Okay, so that's we can use U or we can use V naught. Right? So we want to calculate the maximum height, the range of the projectile. So maximum height, range of projectile depends on angle of projection. Right? It's called the angle of projection, theta. Initial velocity, how fast you throw the ball, or how fast it's projected. Right? And then these are the terms that we use. Velocity of projection. U is called the velocity of projection, or initial velocity of projection. Trajectory, the path taken by the object is called a trajectory. So we usually will replace the vector with one horizontally, one vertically. Right? So one next to the angle is U cos theta. One further away is U sine theta. So this uniform acceleration. Horizontally is uniform velocity. Right? You derive this maximum height equation and then time of flight equation. And then this is called the range from the start to where it reached the ground. Formula. So usually it's better to know how to derive it rather than memorize the equation. Right? There's so many equations. Unless it's objective, got no choice. Objective, you need to memorize it, then you can do faster. But for normal question, it's better to spend time deriving it. It doesn't take a lot of time. That's what we are doing. Right? What have we done? We treat the motion in a plane or two dimension as combination. Right? Combine of independent vertical and horizontal motion. That means there's a vertical motion, there's horizontal motion. We combine the two together vectorly. Vertical motion, Vy, horizontal motion, Vx. Velocity at any time. To determine the velocity at any time, we add vertical and horizontal velocity as vectors. Right? Remember, velocity is a vector quantity. So we work independently. We don't have to worry about two value. We can find it independently. Velocity at time t, and then velocity at time t, and then combine them. Right? Use that vector equation. This is a vector equation. V equals to Vx plus Vy. So we draw a rectangle, complete a rectangle. And then this diagonal will represent the resultant vector or resultant velocity. Derivation of maximum height, time of flight, and range. Right? Let's look at the physics involved. First thing is to resolve u, the initial velocity, right? Or you can call it v naught. Theta is the angle of projection. U is the velocity of projection. Right? We solve in the vertical component, uy. Right? U in the direction of y. So it's u sine theta, further away from this angle. And then we got Vx, horizontal component of velocity. So it's u cos theta. Theta is angle of projection. X is horizontal distance. This horizontal distance. Right? Maximum height. Now we just consider vertical motion. And remember, it's a vector. So we have to choose a direction. You want positive, and which one is negative. Right? So we take upwards as positive for our choice. Consider vertical motion. Right? Initially, u is 0. Acceleration is downward, so it's negative, minus g. Maximum height, s equals to h. Choose the right equation. This is at maximum height, the velocity, the y component is 0. This is the initial velocity, right? In the y direction, this one. This one is the final velocity at the maximum height. It starts to decrease to 0 at maximum height, and then it changes direction. Choose the right formula. V squared equals u squared plus 2as, substituting. Right? Vy is 0. U, this one, square that. Then 2a is minus g. S is h. Then simplify that, we get our equation. Take this one across there, take the 2g down. Okay. Time of flight. Various authors will use different name. Time of flight. Time the body is in the air. Then we consider vertical motion because if the time is spent in the air is short, then the distance horizontally also will be short. So if we spend the longer time in the air, then we will have longer time of flight. Consider vertical motion same. What is given? This one. This one. U sine theta. A is minus g. We are interested in time. Right? We can consider where it comes down, going the same velocity, same speed, except negative because it's going down now. Right? Choose the right equation. All this given. So the right equation is v equals u plus at. Put in your value. Right? V is just that. U is just that. That's a u. A is minus g and t. Take this one across there. This one across. Gt equals to 2u sine theta. Something across there is 2u. And then we can take our g down. That is what we get our equation. Right? We have derived that time of flight. Range. Right? Range is horizontal distance move. So we consider horizontal motion. Right? Range is the distance traveled horizontally when the body returns to the ground. So here we consider horizontal motion. And remember, as a horizontal motion, no acceleration, uniform velocity. So distance move horizontally is just the speed of velocity times your time. So the horizontal speed, ux, Right? We write a mathematical symbol, horizontal velocity times time. Horizontally is u cos theta. Time of flight, that's our time of flight. Write that in and use a bit of trigonometry. Remember that 2 sine theta times our cos theta there becomes sine 2 theta. So replacing that, got our u square, u and u square, and the other is sine 2 theta g. How to get maximum range? Remember, we are not looking at this one. We're looking at this side, this stage, same height, same level. You send it from the ground, come down on the ground. Not this one. This one is different height. Okay, examiner may ask you. We're not interested in this type. That's why we say same level. Range is just that. So maximum distance is where, remember this is sine 2 theta. Maximum will be this one will be 1. Right? This one will be 1. So maximum range occur when sine 2 theta equals to 1. Right? This one, the highest you can go is 1. Right? Usually it's less than 1. So if this is 1, then your 2 theta equals 90 degrees. So theta is 45 degrees. Right? So that's the reason why when you throw a javelin, you have to aim it at the right angle. Right? Remember, this is the same height, but throwing a javelin is usually of different height. Right? So if that is 1, then your maximum range is u square over g. Okay, this angle is 45 degrees. Right? As I say, it's better to derive rather than memorize the formula. Right? Time of flight, time the object is in the air, or 2 times time to reach maximum height. Right? Time to go up to maximum height, time to count down from maximum height to the ground is the same. That's why it's 2 times. Right? Time to go up is equals to time to go down. Effect of air resistance on the path of projectile. This is a path where there is no air resistance. Right? Without air resistance, it's a parabolic path. That means you draw a line through the vertical through the maximum height. The two are symmetrical. The resultant force acting on the projectile is the weight of the projectile. Right? Usually we use a heavy object, then air resistance will be negligible. Right? So the thing that's acting is the weight. Right? So in this case, no air resistance, upward acceleration or deceleration is decelerating when it's going up. It's the same as the downward acceleration in magnitude. Right? With air present or air resistant, vertical motion, when moving upwards, the cannonball would encounter greater retarding force due to weight and air resistance. Okay, we will study this in topic 3. The weight is pulling it down. Air resistance is also opposing. It's moving up. Right? It's moving up. So air resistance is downwards, opposing it. Another force, previously only the weight. Now we have air resistance and weight. So the acceleration is going to be greater, or deceleration is going to be greater. Right? So previously it's this parabola. So now with air resistance, it won't reach maximum height. The maximum height is going to be lower. Right? So that's the actual path. Vertical speed decreases much faster, right? Because of greater force acting or greater deceleration. So we can expect the maximum height to be lower. Horizontally, ball is subjected to, example will be football, kicking a football. right? Because the football is a lighter and heavy object, so it's going to be air resistant. Ball is subjected to deceleration due to air resistance. Right? Normal uniform velocity is now decelerated motion horizontally. Speed of ball decreases. So if the speed decreases to 0, then you will drop down vertically. The range of the ball will be shorter, right? Because horizontal speed is now lower. Vertical height is also shorter. Vertical height is shorter, so the time is also going to be shorter, so it won't go further. Right? Shorter range. Remember, velocity at any time, right? Just a summary for same level. Vertical velocity, resultant velocity is velocity in x direction plus velocity in y direction. This is a vector equation. Right? To determine maximum height, consider vertical motion. To determine the time of flight, consider vertical motion. Determine the range, consider horizontal motion. That's all you need to remember. Rather than memorizing the formula, derive the formula. So these are what we have learned. You can summarize with your own mind map. You can remember what you are doing. Right? Trajectory, rate, uniform, velocity horizontally, no air resistance. There's your vertical velocity, initial vertical velocity, uniform acceleration vertically, there's a maximum height, there's a time of flight formula that we derive, and there's the range. Okay, so thank you for your time. Next YouTube session, which will come later on, will be using all this formula, right? How to solve problem in 2 dimensions. So we'll stop here for today.